Hello viewers, let's quickly look at this geometric ratio of spatial angles: 30 degrees, 45 degrees and 60 degrees. I want us to know this. Anytime you see sine 30 degrees, you don't need to look for calculator to punch it or look for table to search for it. You can use a triangle and get there. Please stop cramming geometric ratios, please. Now, I'll show you here how to do it in a simple way. Now, look, let us consider an equilateral triangle. What is equilateral triangle? Equilateral triangle is a triangle that has the three sides equal, meaning that all the sides are equal. So this equilateral triangle now, let me say that this equilateral triangle will have 2 units each. 2 units each. That is because the equilateral, all sides must be equal. Now, let me call this equilateral triangle X, Y, Z. Now, this is the equilateral triangle of X, Y, Z. Now, if I bisect, remember that a triangle, this place now, in a triangle, so the sum of angles in a triangle equals to 180 degrees. It means that if here is 60 degrees, here is 60 degrees, and here is 60 degrees. If you sum this angle now, it will give you 180 degrees. That is why the theorem says the sum of the triangle, the sum of angles or interior angles of the triangle equals to 180. Now, what if I now bisect this place now? I bisect here. This 60 that is here, I will divide it into 2, 30, 30, still 60, because I'm looking for 30. Now, if you look at this now, you see that the bisection here have made this equilateral triangle to create 2 right angles. This is a right angle, this is a right angle, and they are all equal. You can pick any one to work with. I can pick this side, it's still the same thing with picking the other side. Okay, let me pick one side of it. Look at one side of it. This is the right angle. This thing here is the symbol of right angle. It's showing the hypotenuse side. Whenever you see this, remember that this is different from curve. Curve is showing the opposite. Why this one is showing the hypotenuse? This one is showing hypotenuse. Why the curve is showing the opposite? Now, if you see this thing, look at the angle here. This is Y here. This is your X. This is the. I will call this place N. Remember, if I bisect this place here, I can call this place 1, 1 because there are 2. 1 plus 1 is 2. Yn, line Yn is equal to line Nz. Okay, this is Yn here to here, Nz here to here. They are equal. And if you add 1 plus 1, it gives you the 2 units, and the other side is. So now let's quickly look at this now. This is 1, this is 2. How do we get this? This is a right angle triangle. Remember, I told you that this goes with opposite. This one goes with hypotenuse, and this place is adjacent. Now, looking at this now, you see, for us to get this side, we use Pythagoras. Why? Because it is a right angle triangle. So we now say, as our here is A, we say A squared equal to hypotenuse, which is 2 squared, minus opposite, which is 1 squared. 2 squared is 4, 1 squared is 1. 4 minus 1 will give us 3. That means A squared equals 3. But that is not what they asked us. They said A. So for us to remove the square, we add square root to both sides. Square can cancel square root. We have A equal to root 3. Therefore, this side now, adjacent side will be 3. So now let us quickly look at that sine 30, cos 30, and tan 30 degrees. Now looking at it here, we already know this acronym here. SOHCAHTOA. This SOHCAHTOA, this is sine, opposite of hypotenuse. Cos, this is the hypotenuse. Tan, opposite over adjacent. I know you know this thing now. So what we do now, we say sine 30. Sine 30 degrees. Remember, this is opposite. Sine 30 degrees, according to the list, is opposite over hypotenuse, which is the same thing as, where is the opposite? Is your 1. Because of this, 1 is my opposite. Where is my hypotenuse? Is already here. You have 2. That means sine 30 is 1 over 2. Now, cos 30 degrees, remember the acronym here. Cos 30, cos is adjacent over hypotenuse. Adjacent over hypotenuse. Where is adjacent? Root 3. Where is hypotenuse? 2. That means cos 30 degrees is root 3 over 2. Now, let's quickly go to tan 30 degrees. Tan is tangent. Tan 30 degrees, which is tan opposite over adjacent. I will have opposite over adjacent. Now, opposite over adjacent, where is the opposite of 30? This is 1. You already know it's 1. Okay, we have 1, and then yes, adjacent is root 3. I will have root 3. 1 over root 3. Yes, 1 over root 3 is correct. But in short, I think you can do it this way, rationalize it. Why am I rationalizing it? Because root 3 is not good to root 3 to be a denominator. What I will do now is 1 times root 3 will give me root 3. Remember that root is root 3. Root 3 times root 3 will give you root 9. Root 9 is a reference square. Is 3. That means square root of 9 is 3. So this is the tan 30 degree is 3 over 3. The next class now we are going to look at sine 60, cos 60 degrees, tan 60 degrees, sine 45 degrees, cos 45 degrees, and so on. So that is where we are going to stop for today. Bye.